Greetings, junior scientists, and citizens of this great, big, weird, wild, wonderful world in which we live. As always, I'm your humble science communicator, the great Orbax, coming to you from the Department of Physics at the University of Guelph. I'd like to welcome you to our November 2022 Stargazing Guide. Even though the clocks fall back an hour on November 6th, our night times are getting longer and longer this month, with sunrise occurring as late as 7:30 a.m. by the month's end, and our sunsets taking place as early as 4:40 p.m. And while it may be getting cold out, this gives us a whopping 15 hours to stargaze, junior scientists. This month we look for the return of our mythological family constellations, check in on the planets, and wake up early to see the last lunar eclipse until 2025. So many exciting things to discover if we just take some time to look up. In Greek mythology, Cassiopeia and Cepheus were the queen and king of ancient Ethiopia. They can be seen high in the northern sky throughout November and are actually pretty easy to spot. Cassiopeia can be seen sitting in her chair staring into her hand mirror. Typical Cassiopeia. And quickly identified by the big W asterism shining bright in the sky. Just slightly to the west and a few degrees lower is her husband Cepheus. Now, I always had a hard time finding Cepheus until I started looking for the home plate in the sky. Spot the W and then slide on home to Cepheus. Continuing up and to the east, you'll find their daughter Andromeda. Now, Andromeda got into a little bit of trouble when Cassiopeia claimed that she was more beautiful than the Nereids, the companions of Poseidon. You can see Andromeda right next to the winged horse Pegasus that we talked about last month. I wonder if these legends all have something to do with each other. Read a book! While last month gave us an abundance of planets, this month we lose visibility of Mercury and Venus. While last month gave us an abundance of planets, this month we lose good visibility of Mercury and Venus. That said, Mars, the planet of robots, is visible bright in our sky throughout the month with a characteristic red-orange hue, and visible close to the moon on the morning and the evening of November 11th. The gas giants Jupiter and Saturn continue to light up our evening skies, with Jupiter bright and beside the moon on November 4th and 5th. Make sure to check out Saturn early this month as it loses altitude throughout November, making it increasingly difficult to see. Our full moon this month occurs on November 8th. This month's full moon is known as the Beaver moon, named for the time of year when the beavers hurriedly collect their food stores and hide them in their lodges for the long winter ahead. The Anishinaabe people call this moon Gashkadino-Gizis, the freezing over moon. The Mi'kmaq people of eastern Canada call the November full moon Gepdagewigus, the river's freezing over moon. And the Cree Nation call it Gagastanawipism, the freeze-up moon, all referring to the dramatic drop in temperatures that occur at that time of year here in Canada. So this month we not only have a full beaver moon, but we've got a full beaver blood moon. That's right, a full lunar eclipse will be taking place in the early morning hours of November 8th. And as it turns out, it'll be the last full lunar eclipse that we'll be able to see until March 14th, 2025. Pi Day 2025. So what exactly is a lunar eclipse? You're likely familiar with a solar eclipse. Now, this occurs when the moon passes between the Earth and the sun. But what's a lunar eclipse? Well, a lunar eclipse occurs when the moon actually falls into the Earth's shadow. But the moon appears to line up with the Earth like this twice a month, during new moon and full moon. So why don't we have eclipses twice a month then? Well, it's actually a little more complicated than that. The plane of the moon's orbit around the Earth is actually tilted with respect to the plane of the Earth's orbit around the sun. But here's the thing, the moon's orbit stays fixed with respect to the stars, meaning that tilt actually changes with respect to the Earth. And twice a year, it actually lines up in such a way that the moon passes through the Earth's shadow, and that is when we have a lunar eclipse. As the moon passes through the Earth's shadow, it'll still be visible, and it might even have a red tinge to it. So why is that? As light passes through the Earth's atmosphere, it's scattered, meaning that shorter wavelengths like blue light are actually diverted away from the moon, whereas longer wavelengths like red light are what pass through and illuminate the moon. As a matter of fact, if you happen to be standing on the moon during the lunar eclipse, you'd actually be bathed in a red glow and see a red ring emanating from around the Earth, which is all that remains of the light escaping Earth's atmosphere, of all the sunrises and sunsets that are taking place along the edge of the Earth. Now, unlike a solar eclipse, it's perfectly safe to look at a lunar eclipse with the unaided eye, binoculars, or a telescope. Here at the University of Guelph and in most of North America, we'll be able to see the lunar eclipse in its entirety. It will begin at approximately 3 a.m. on November 8th when the moonlight starts to dim. Around 4:30 a.m., areas of the moon will be covered in darkness, and the full eclipse will take place between 5:17 and 6:42 a.m. when you'll be able to see that red glow that we talked about before. The moon will continue to be in shadow until it sets here around 7:10 a.m. Eastern Time. Well, that's November, junior scientists! As we get closer and closer to the winter solstice, our night times of stargazing continue to grow. And I know it's getting colder, and you can't always take the time to get outside, but isn't it amazing? Just think about it. Whether or not you get a chance to go outside and observe it, our planet still continues to wander through its orbit, spinning throughout space as we spiral through our galaxy. The universe continues its dance even when we don't have time to observe it. But maybe tomorrow's a warmer day, and maybe then we can take some time to look up. See you next month, junior scientists, and don't forget to have a science-tastic day. Special thanks to Royal City Science's own planetary geochemist, Dr. Glynis Perrett, for her help preparing our stargazing guide. And the Royal Astronomical Society of Canada